Scientists claim that the magnetic poles of the planet have repeatedly changed places over the entire period of its existence. This phenomenon is called the inversion of the magnetic poles. And according to all the signs that researchers are observing now, this may happen in the near future. What gives scientists reason to draw such conclusions? Is there a threat to all of humanity? Let's figure it out together. Scientists from different countries register that since the 1990s, the movement of the North Magnetic Pole has accelerated fourfold and now covers about 65 kilometers per year. A significant deviation of the magnetic pole is called an excursion. Also, now the magnetic field loses 20 nanotesla a year, the global average. In other words, it weakens by 5% per century and has decreased by 10% over the last 150 years. This is a very alarming signal. Philip Livermore from the University of Leeds, United Kingdom, and his team are trying to find the answer to the question, why is this happening? 3 years ago, the researchers noticed that the magnetic field in the northern polar regions is changing significantly and rapidly. These changes form a kind of a daisy from alternating zones of abnormally weak and abnormally strong magnetic fields. Sometimes the field strengths in the petals change to a value equal to half of the total magnetic field strength of the planet in just one season. As scientists assume, in the last third of the last century, such petal located under Canada has sharply changed the form. Its borders have strongly expanded, due to which the force of its influence on the magnetic field of the Earth has weakened, and the movement of the pole towards Siberia has sharply accelerated. As a result, Livermore notes, 2 years ago, the magnetic North Pole crossed the date line and officially ended up in the Eastern Hemisphere. This daisy chain, scientists explain, is produced by a powerful and very fast stream of molten metals in the upper layers of the core, which moves 3 times faster than the surrounding rocks and thousands of times faster than the colliding or diverging continents and tectonic plates. Geologists believe that this unusual flow within the outer core occurred due to the fact that the liquid component of the core at the point where it exists is literally squeezed out by the 2 layers surrounding it, causing the molten iron to move at an unusually high speed and accelerate its movement. These jet streams, as Livermore and his colleagues show in their calculations, should influence the speed at which the planet spins. The planet's rotation is now accelerating rapidly. To understand the danger of the pole drift now, another group of scientists decide to study in detail the movement of the magnetic poles in our planet's history. Recently, they published the result of a first-of-its-kind research that reconstructs from circumstantial data the events associated with Lachamp's magnetic excursion. Scientists from 9 countries took part in the work. The starting point was the huge fossilized trunks of a kauri tree discovered in northern New Zealand, which had lain in peat soils for 41 to 42,000 years. By analyzing the width and composition of the annual rings, scientists drew conclusions about the environment over 1,700 years, just before and during Lachamp's excursion. The researchers also studied the chronicle of the magnetic field in rocks and traces of cosmic rays in the ice of Antarctica and Greenland. They found that for about 1,500 years, the Earth's magnetic field had been decreasing, and so the protection of the planet's surface from the flux of ionized particles. The solar wind and cosmic rays had been weakening. Researchers have been able to determine that the planet's defenses decreased by 90% during the Lashamp excursion in the past. This is confirmed by the carbon, beryllium, and oxygen isotope ratios in the ice layers of that era. The same period also accounts for a series of solar minimums. Combined with a weak geomagnetic field, this created the condition for a perfect storm for the Earth. During this period, strong cosmic currents bombarded the planet with a great force. The ozone layer was nearly destroyed, and the planet's flora and fauna was exposed to harsh ultraviolet radiation. Researchers developed a detailed chemical climatic model of the Earth's atmosphere, taking into account various internal and external factors. The simulation showed that during the Lashamp excursion, the amount of ozone above the Earth's surface fell by about 5% and by 10 to 15% at low latitudes. Accordingly, the UV flux increased by the same amount, especially near the equator. Ionization of the stratosphere jumped by several orders of magnitude, and aurora borealis covered the entire planet. The global climate system changed. Northern Europe, Northeast Asia became warmer, while North America became colder. Australia became a desert, and many species became extinct. At low latitudes, cloudiness increased dramatically, and thunderstorms became more frequent as electrical storms were generated in the ionized air, which was a perfect conductor of electricity. It was around this time that the Neanderthals disappeared, and the modern humans, those of the Oriental culture, began living in caves. It looks like the end of the world, says the study leader, Professor Alan Cooper of the South Australian Museum of Natural History in Adelaide. This is the first time scientists have directly linked magnetic pole drifts to large-scale changes in nature, and they've done so on the basis of accurate radiocarbon analysis. Previously, geomagnetic fluctuations were thought to have little or no effect on the Earth's climate and biosphere. The current weakening of the magnetic field, according to the authors of the study, may indicate the approach of another inversion. Scientists say that such catastrophic changes are caused by processes taking place in the Earth's core. It is known that global cataclysms associated with the impact of cosmic rays on the Earth's core occur on a planet with a periodicity of about 12,000 years. Ozone depletion increases in cosmic radiation, dramatic climate changes, and an increase in natural disasters are still occurring on the planet, just as they did during the Lashamp event. It is important to carry out as much comprehensive international research as possible to unite the efforts of scientists to study the causes and develop protective mechanisms to prevent global catastrophe. This requires the unification of humanity in a new, creative format of society in which the life and safety of each person is of the highest priority.